Hello, this video I'm going to start introducing you to differential equations. It's something you're already familiar with. Think of the following example. Now this, although to you it just seems like the derivative of something gives you x squared, is actually already a differential equation. And if you're asked to solve it, this is what you're supposed to do. You're supposed to get rid of those differentials so you can end up with a nice and familiar function. So how do you do that? In this case here, what I'm going to do is I'm going to take this dx to the other side. So what I end up with. And now if I put integration signs on both sides of the equation, I can integrate, and hence I end up with my solution. This will be called the general solution. So from this equation, we ended up with a nice and normal function. Now we can do normal analysis. We can draw that function in our traditional ways. So that's an advantage. So getting rid of the differentials is called solving a differential equation. And these can be extremely complicated. And you probably dedicate years of study if you do engineering to more and more complex differential equations. It's a whole world in itself. So let's get started just by defining a few. So we talked about this situation here where this is called a differential equation, right? This will sometimes be referred simply as the rate of change, remember, or perhaps the derivative, or even y prime. So I can move these d's around, and now the dx, the differential of x, can move to the other side. And I integrate and I get my solution. Now this solution here is the general solution. And it's very important, and this is a common mistake, to forget to put that c and to use it properly, to put it where it belongs at all times. Now, it might be the case that they give me a given point, and hence I can already calculate the value of c. This would be a particular solution of the differential equations, a given value of c. So sometimes they'll give you a point, and that's how you figure out the c. So the technique that we've been using right now is the most simple of them all, which is just to separate the variables. Realize that that's what we've been doing. We had equations like this one, and what we did is we just made sure that all take the dx to the other side of the equation, and take everything that has an x to one side of the equation and everything that has a y to the other side of the equation. So you ended up with something like this. Now you see I have every y on one side of the equation and every x on the other side of the equation, and the dy with the y's and the dx with the x's. So now when I put the integration sign on both sides, I can just go ahead and integrate. Now occasionally, and this is something that's going to happen a lot in differential equations when you're solving them, some of the integration you'll have to do will actually be quite complicated. Now don't hesitate to just do it a bit aside and take your time, and I hope that you will improve your integration techniques by the time you're done studying differential equations. So just in case you don't know how to do this, pause the video and give it a shot. It's a good practice, but ultimately this is what you're going to get. You're going to get that y to the power of 3 divided by 3 is equal to this plus c. We tend to only put the c on the one of the sides, often the x side. You'll see why in a minute. But the important thing is that when I get to simplify this expression, this is what you're actually going to end up with. Y equals and then all the rest. And this is often the form in which they want you to give the solution. That's why they say they want it in the form y equals f of x, which is essentially this expression. Notice how the c is not something I add at the very end. The minute that I start to clear the y, whatever happens to the c happens to the c, and this is going to be very important because many times that c is going to end up in quite unusual places, and that's going to have an important effect on what the differential equation looks like. So this is an example of separating variables. Here's the differential equation. So again, I'm going to take the y's on one side and I'm going to take the x's on the other. And note that they give me a particular case here. They give me a particular situation, so I'm going to have to solve what c is equal to. So I separate the variables, as I said, and now I integrate, and this is what I'm going to get. Now, because I need to get that y alone on one side of the equation, this is what it's going to look like. And then notice how the c is also to the power of v. Now, if I put the values that they give me, I'm going to get that c is equal to 0, because that's when e to the power of c gives me 1, when c is equal to 0, and hence the general solution of the equation is this one here. Now, this is actually the easiest example, perhaps, that you might even encounter. Very lucky if you encounter this one, but it just sets the example in the general mood. Note the important things here is try to separate the variables, Most of the time you won't really be able to, and you'll have to do something a bit more elaborate. Integrate, and try to leave the y alone on one side of the equation, specifically only if they've asked you to do so. And then substitute and find out what the c is. And hence you give the particular solution of the differential equation. In this case, c is equal to 0. So this is a general guideline of what you will be learning here in general. So separating variables, this easy example that we just did, is going to be the rare case. Most of the time you're going to be doing more elaborate things. This equation here will actually be more complicated to solve. This is a homogeneous differential equation. Perhaps more complicated, we'll see it in the next video. And there are different tricks. You can't just separate these variables. So there's this big world out there of how to solve differential equations. So we're going to just see some of the tricks available, but it gives you a bit of an idea of what this starts to look like. Here are the techniques we're going to be learning. To separate variables, that one you already know, that wasn't very hard. Homogeneous differential equations, which is just a trick to deal with situations like this one here. Using the integrating factor for something called linear differential equations. This one here is perhaps the most complicated one, and here come the other two. Now, Euler's method is not for solving differential equations, it's for estimating a value. And same thing for Taylor series, which we will be using for estimating values. This is it. These are the 5 methods you need to learn. And already you have one. Thank you for watching. Goodbye.